want to clear your concepts regarding buffer solution, right? So let's start. Okay, so now what is common ion effect? Basically the suppression in dissociation of weak electrolyte in the presence of strong electro electrolyte, both having common ion, right? So now what does that mean? Basically the suppression, or you can say the decrease in dissociation, the decrease in the ionization. You can also write over here, um, you can write over here decrease in dissociation. Decrease in dissociation means the suppression in dissociation of in weak electrolyte in the presence of strong electrolyte, both having a common ion, right? Okay, we know that the weak electrolyte already does not dissociates in a well manner, right? It actually in weak electrolyte. Let me write over here, weak electrolyte weak electrolyte dissociates partially. In a normally it is dissociating partially. Now after having the strong electrolyte in the same solution, both having the common ion, it there is a suppression in the dissociation. There is a decrease in the dissociation. Even though weak electrolyte doesn't dissociates well, there's a partial dissociation, right? And but after having another strong electrolyte and both having a common ion in that solution, it dissociates. There's suppression and dissociates, right? So what is common in effect? For example, in a solution, what is that? What's not working? Okay, what is okay? So okay now. Now what is common and effect? For example, in a solution, you have okay, this is a solution, right? You have a weak electrolyte, right? And a strong electrolyte. Okay, I have written here word electrolyte. What does that mean? Your electrolyte can be acid. Your electrolyte, okay, let me write over here. Your electrolyte can be acid, A for acid. It can be base, right? It can be base or it can be salt. Electrolyte means anything, right? Anything which conducts electricity in its molten form or in its liquid form. That is known as electrolyte, right? So here I haven't used the word acid, base, or whatever it can be. It should be electrolyte. Electrolyte means anything that conducts electricity in its molten form and its liquid form, right? So for example, this is a solution and I have had over here a weak electrolyte and a strong electrolyte, right? Weak electrolyte and a strong electrolyte, and both are having the same ion. then there will be suppression, means there will be decrease in the dissociation of a weak electrolyte. Okay, now let's take examples to make your concept more clear, right? Okay. Let me erase this. Okay, let's take the example of hydrogen cyanide. The hydrogen cyanide is basically a weak acid. Hydrogen cyanide is a weak acid, right? Now let's take a strong electrolyte, which is, let's take potassium cyanide. What about this, right? This is potassium cyanide, right? This is potassium cyanide, and this potassium cyanide is basically strong acid, right? It is strong acid, right? Hydrogen cyanide is a weak acid, potassium cyanide is a strong acid. Let's take these both electrolytes in a same solution, right? Okay, let's prepare a container over here. Let's see that this is a container. This is a container, right? Now, what we have over here? Okay. Now, as we know that this hydrogen cyanide is a weak electrolyte, okay, there will be a partial dissociation. Hydrogen cyanide. Okay, let me make the arrows. Right, this is the hydrogen cyanide. It will dissociate into positive ions plus Cn minus, right? Now we have which is potassium cyanide, right? And there will be complete, like there will be 100% dissociation. 100% dissociation, right? Let me make an arrow over here. As this is a strong electrolyte, so there will be 100% dissociation, and what will form basically potassium ions plus there will be formation of Cn negative, right? Now listen to this. Okay, now as I said, this hydrogen cyanide is a weak electrolyte, this potassium cyanide is a strong electrolyte, right? This potassium hydrogen cyanide is weak, potassium cyanide is strong. After dissociation, as the weak electrolyte dissociates already partially, so there will be an equilibrium, right? There will be forward reaction and backward reaction. It is a reversible reaction. This is potassium cyanide, so there will be 100% dissociation with potassium ions plus cyanide ions right over here. Now, as I said, the suppression, what is the statement? The suppression dissociation of weak electrolyte and presence of strong electrolyte both having common ion. This cyanide, this cyanide. Both are common, right? Both are common. Now what will happen in the solution? The concentration of cyanide ions will increase. The concentration of cyanide ions will increase, and then, okay, Here's another concept which we'll study in ionic equilibrium basically, but let's give an overview over here. Le Chatlier's hmm, Le Chatlier's principle. Okay, now what is this? Basically, according to Le Chatlier's principle, when when there is equilibrium, like this is a equilibrium. What is equilibrium? That there will be a balance, certain balance will be there, equal amount of reactant and equal amount of product will be there, right? Somehow you can say this. Okay, when there's equilibrium and and same ions come in product side, when it will combine with other product and forms reactant. Now what does that equation means, that statement means? Now look, this cyanide ions are increasing, right? These are on the product side, right? These cyanide are on the product side and the product is increasing as there is a common ions, right? The strong electrolyte is also dissociating into common ion into cyanide, and the weak electrolyte is also dissociating into the cyanide ion. So there will be an increase in the concentration of the cyanide ions. Now what is Le Chatelier's principle? According to the Le Chatelier's principle, when there is increase in the product side, now this product will combine with another product, which the another product over here we have is this hydrogen ions, right? This cyanide will combine with hydrogen ion and they will form hydrogen cyanide. So as you see that already there was a weak dissociation, now there is a suppression, now hydrogen cyanide is forming, right? Already it is a weak electrolyte, so there was partial dissociation. Now after having this potassium cyanide in the solution, after having this common ion, there's even more partial dissociation. Even hydrogen cyanide is now forming, despite instead of dissociating it is forming. So obviously there is a suppression in dissociation. That suppression dissociation is known as common ion effect. Let me write over here. I hope you understood this. Now what will happen, this CN will combine together with hydrogen ions to form hydrogen cyanide to balance the equilibrium. So thus this equilibrium, now there will be equilibrium will shift backward. It means that equilibrium will shift backward. This equilibrium will shift backward, as I said. This equilibrium will shift backward, right? So this shifting of equilibrium backward and suppression, the dissociation of the weak electrolyte in the presence of same ion is known as common ion effect, right? So I hope this is clear to you. If you have any kind of questions, you can ask me in the comment section. I'd be really glad to answer you guys.